Hi, welcome to another video on experiments in math. It's actually something which I believe we just don't do enough of today. A lot of math has become very problem solving oriented. There's a puzzle or a problem and we just try to solve it and we're done. But math can also be experimental. Okay? Let's take a particular case study. 3, 4, 5 as the sides of a triangle form a very unique relationship. Pythagoras, the Greek polymath, showed that a square plus b square is equal to c squared in a right angle triangle. This we call as the Pythagoras theorem. 3, 4, 5 is considered a Pythagorean triad, but there are many more. How many can you find without doing a search on the internet or asking ChatGPT? So today's experiment is about figuring out Pythagorean triads. You don't write a program, you do not go to ChatGPT, you don't go and search on internet. All you have is paper and pencil and the Pythagoras theorem in front of you. Can you figure it out? So you start with 3, 4, 5. You could possibly figure out 6, 8, 10 if you were to just play around with it. Maybe you even figure out 5, 12, 13 by just iterating if you are a really dedicated person who's trying to figure this out. But how can you determine more triads though? That's the question. So to do that, you need to go to the abstract and find the concrete. So what do I mean by that? Now remember, let's assume for a moment, even though we don't know for sure, that there are 100 more such Pythagorean triads. What's common between all 100 of them? And I want you to just recollect my definition of intelligence, knowing differences between similarities and similarities between differences. So if I have 100 different triads, we know they are Pythagorean triads. Let's just assume for a second they exist. They're obviously very different set of numbers, but each of those 100 sets have something in common. What is that? They all follow Pythagorean theorem, which means a square plus b square is equal to c square. So if you write them in ascending form, a being smallest, b being the next one, and c being the largest, and c would be the hypotenuse, a and b would be the two smallest sides of the right angle triangle, and they would all follow the same rule of a square plus b square is equal to c square. So that is your clue. Go. So in the abstraction, a square can also be written as c square minus b square for ABC being in a Pythagorean triad. So algebra would tell you that c square minus b square is nothing but c plus b into c minus b. And let's assume b and c to be adjacent numbers, which means c minus b has to be 1. If that's the case, then a square is equal to b plus c. So you also have to realize that a has to be odd here because b and c are adjacent numbers. Some of those will be odd and the square of an odd number will be odd. Putting all of these together logically, you would conclude that a has to be odd. So just let's iterate through odd perfect squares to see if we can split them into two numbers. So here's an example. So let me take the first 6, 3, 5, 7, 9, 11 and 13. So you know the perfect squares are 9, 25, 49, 81 and 121 and 169. So if you take the example of 9, so two numbers need to add up to 9, adjacent numbers. So which means you subtract 1 divided by 2 to get b. Add 1 to b, you get c. And let's check it and it works. That's the very basic Pythagorean triad, which is 3, 4, 5. Similarly, if you take 5, you know that 5 square is 25. Subtract 1 from 25, you get 24 divided by 2 to get b. That's 12. Add 1 to b, you get 13. And you check it and the answer is right. Same thing for 41. Subtract 1 divided by 2, that's 24. 24 plus 1 is 25. So 7, 24, 25 is also a Pythagorean triad. And as you can see, it doesn't stop here. You can keep on going infinitely because you have infinite number of odd numbers. And this particular algorithm of taking an odd number, squaring that, subtracting 1, dividing by 2 to get the other, the value of b, adding 1 to b to get c, would give you an infinite number of Pythagorean triads because that's the beauty of math. Okay, you could say, why should I assume a and b only to be adjacent numbers? Does it mean that all Pythagorean triads should have a as odd? Not really. Here comes the next assumption, which is to say that let b and c be apart by a difference of 2, in the sense C is equal to B plus 2, in the sense B could be odd, C could be odd, or B is even and C is even. A difference of 2. Now in this case, you know that A square is B plus C times 2, which means A square divided by 2 should be B plus C. Now B and C both are integers, which means A square by 2 also needs to be an integer, and this will logically tell you that A has to be even for this to work. Now let's just iterate through even perfect squares to see if we can split them into two numbers. So let's take the first 6 even numbers, which is 2, 4, 6, 8, 10 and 12. The perfect squares divided by 2 would make it 2, 8, 18, 32, 50 and 72. To get the value of B, all you have to do is split that, which means you can subtract 2 this time and divide it by 2. So 8 minus 2 is 6, 6 divided by 2 is 3. And if you follow the same process, we discovered that many of them are repeats, but 2 of them are unique, which is 8, 15, 17, 12, 35, and 37. Now, why is it so important? Let's take an example of a question that appears in a high-level Olympiad exam. It just says triangle ABC has sides 12, 35, 37. Find the angle BAC. And probably you'd be stuck. You would, if you didn't recognize that this was a Pythagorean triad, you'd be all over the place. But if you did recognize it, all you have to do is find the tan inverse of 12 by 37 or 12 by 35 and you're done. But in the absence of that, it would be a wild goose chase. So here's the next step for you to think about. Engage in experimental math. How? Make a list of all the perfect squares and cubes. Get familiar with this. This is nature's patterns through numbers. So understand perfect squares and perfect cubes. Write down the powers of 2. When we keep doubling numbers, what are the numbers we reach to? Get familiar with those. List down all the prime numbers. Get familiar with those. Now, math is such that numbers form the building blocks with which you get higher level concepts. And many children struggle with higher level concepts because they're not comfortable with the numbers itself. We don't spend enough time playing around with it, experimenting with it. So I would strongly suggest that you consider doing all of this, because this will really help you, your kids, or anybody you're interested to help out with math, to just go and experiment with math and numbers especially. I hope you found this video useful. If so, please click on the subscribe button and the bell icon. Share the videos. Hope to see you in the next one.